Okay, can everybody see my screen?
Aye,
All right, so simple class, person, right? Now, let's say that there's a dependent entity. Say street. List of addresses. List of address.
Yep.
Okay. Now, let's say that you want to, let's say that you have a list of people. Right? List of person. One second. Is my default tab, sorry, one second. Is my default tab for some reason? No.
Oh, the tab spacing is in the bottom right corner.
Oh. Oh, nice. Nice.
There we go.
Cool. Okay. I did not know that. All right. So, person, let's say Joe. Let's say Joe is 33. He has a list of addresses. Address 123 street. Say address 456 street, right? So those are his addresses. We can have another person, Jack, right? Jack 44 or 444 list. He has one address, right? 999 street, etc., etc. Not very creative, right? So let's say that you have this list, right? And then let's say you want the street names of everybody. Let's say that you want just all the street names of everybody combined, right? Just the street names, right? So how would you do it? Well, in good old Java, streets list of string. So let's say you just want the streets, right? What do? Well, in Java, you write a good old for loop. New array list, blah, 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 blah. Right, for, and then you do A, or you do P in people, right, and then you do for A in addresses, or sorry, P dot addresses, right, and then you put into this stupid thing, streets dot add A dot street, right. Well, okay. This kinda gets nasty pretty quickly. Let's introduce another level to our hierarchy. Case class, let's say companies, places of employment. Company has a name, string, and employees, or people. Right? A list of people. Right? Then, so how do you do that? Right, in this case, we're defining not people, but we're defining companies, right? Right, so company is going to be company, and company is going to have a name, right? Let's say Microsoft and a list of employees. And then some other list of, or excuse me, then some other company. Let's say Intel. And then some other, a name and some other list of employees. Right. Da-da. And then we have a list of these. Da-da-da. Da-da-da. List of these. Right, etc., etc. So we've just made our hierarchy one level deeper.
Yep.
All right. Now let's say we introduce a list of countries. Each country contains a list of companies. Case class, country, name, string, companies, list of company, right? And you can imagine what I'm going to do here, right? That, and then inside I'm going to have a country, right? And the country is going to have this list, USA, right? And then there's going to be a list of those countries, right? See what I mean? So we're just adding more and more and more levels of depth to our giant hierarchy, right? Now, let's say I want to go into every single country and every single company, every single person, and get their street address. So what do I do? Good old for loop, right? So I just add layers to the for loop. For C in, for, let's say, CO. What did I, oops. For CO. In fact, let's start from here. For C in countries, and then inside of there, for CO in country.companies, and then, and then all of that now goes inside of here. Right, for co.people, for a.address, streets.add. Okay. Now, this is getting real ugly real fast. Say that we want only the countries that start with U and the people whose names start with J. So, how do you deal with that? Well, you add some more layers in between. If C dot starts with country dot starts with U, and we want only the people whose names start with J, so add another if statement. If P dot starts, P dot name, sorry, for countries it's also country dot name. If person dot name dot starts with J. Great. So, everybody here?
Yep. Yeah, that's a lot of psychomatic complexity.
Yes. So this starts to turn into a giant pyramid of death really fast, right? Well, how do we control for this, right? Is there a way that we could do better? Okay. Well, let's see if we could do better. Let's say that we only have people. Let's start with people, right? Right, people, that's going to be list of person, right? Val, people is going to be a list of person, right? We know what this looks like. Let's say we want just the addresses. Let's say we want, actually no, let's say we want just the names. Names, right? So again, we could do a for loop, right? We could do for P in people, and right, and then we could do val names equals to list string equals to new array list blah 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 names equals or names dot add p dot name, right? We could do it like that. Or here's another proposition, names equals to people dot map. What is a map? A map is a lambda function that takes P of type person, but you don't have to spell that out, P to P.name, right? That's a little easier, right? We just have a lambda that says, given a person, here's his name, right? That's relatively decent, right? It's understandable what's going on here.
Yeah, of course, yeah.
So, okay. Now, here's the thing. We want... Oh, and then, by the way, we've got names and then ages, for instance, p.age. Right? Age is gonna be list of int. Right? Oh, excuse me. What is it left? Huh? Okay, go to bed, and then in 10 minutes I'll get Sorry about that. Okay, so those are ages, right? Names, ages. Let's take person again, right? Imagine that we had another type here that was called foo, of type foo, right? What would happen if we did the same thing, right? People.map p2p.foo, right? What would we get, right? We would get foos. That would be list of foo.
Foo. Okay, yeah.
Everybody with me so far? So, but we want addresses. We want the full list of addresses of everybody. Let's start with addresses, and we could do street names a little bit later. Let's start with addresses. Well, what happens when we do people.map p2p.addresses? What do we get? What do we get when we do p2p.addresses?
List of addresses.
But what is this going to be? What?
Oh, that's going to be address. Right?
For map?
Oh no. That'll be list of address.
With a list of addresses.
Yes. Right? Because whatever this type is, that type is. So it's list of address.
Yep.
Right? If it's an int, that's the output type. Age. Whoops. The output is an int. If it's a name, output's a name. If it's a foo type, output's a foo. Oh, if the type happens to be list of address, it's going to be list of address. Right? Good so far? So, what do we do about this? Right? Clearly, we want to concatenate all the addresses, right? This is going to be a list of everybody's addresses respectively, right? So the list in this case, it's going to be this. It's going to be yay and yay, right? That's going to be the output of this thing. But we want the concatenated list of the addresses, right? We want to concatenate all these sublists. So what do? That is why we have a command called FlatMap. And what FlatMap will do is it will concatenate all of these lists into a single list. Oops. So FlatMap concatenates the lists. So, now, given that we have FlatMap, and given that we have map, how can we try and, well, first, let's get the street names. Let's get the street names, right? We don't want list of address, but we want list of string. How can we go from address to string? What kind of operation can we add here?
Another map. Right?
Another map. Dot map. Right? P2, or this is going to be actually A2, A dot. Dot what? Right? This is an address.
A dot address.
Huh?
No, you need street, right? No, can you show me the definition
Yeah.
of address?
A dot street.
Yeah.
Oh yeah, let's go back to the definition of address. Let's copy
Yeah,
that.
street, yeah.
Street. Okay. Yeah.
Yeah.
I probably.
There's person, there's address. A dot street. Okay? Now, so this map to A dot street, so this thing that we've done here effectively is the equivalent of this. Right? In fact, in Scala, you don't really need to specify the type, so you can just do that. But anyhow, right? So, okay, 5 lines of code has become 1. That's nice. But here's the other important thing. Here's the other important thing. The other important thing to note is that in here, right, let's say you want the person's name concatenated with the street that they live on, right? Let's say that you want something like a string that represents, let's say, Joe, and then dash 123 street. Well, what you can do is you could say p.name plus that plus that. But you can't really do that with this construct, right? Because over here, there's no more p variable anymore. So that's an issue. But here's the thing. If you look at this a little bit closely, what's the output type from this expression? The output type from this expression is list of address. Now, what's the output type of this expression? Well, it is also list of address, which means that you can just take this little map and you can move it in here. So that means that, let's compare, that this is the equivalent of this. Or let's write it out a little bit nicer. This is the equivalent of this. So basically, this form in which it's completely flat and this form in which it's nested mean the same thing. And this is a very sort of fundamental aspect of Map and FlatMap to understand, that their meaning flattened and their meaning nested is the same thing. That's where their power comes from. But anyway, now since this thing here is inside of this thing here, well, we could just do the same thing that we did up there. Right? We can't do it in here. But if we nest them, we can do it. Now, let's see if we can start taming this giant pyramid of death. Now, let's take out the if statements a little bit. We can start a little simpler, and then we'll put them back in. Right. Let's say if we can tame the pyramid of death. Well, how about this? Countries.flatmap C2 C dot companies dot flatmap company CO to CO dot people flatmap P person to P dot addresses dot, and at the very end map, because why is this what goes here? How about this? What goes here? We went all the way down to addresses. What do we do now?
There's not going to
Get
be
the street.
Right.
We get the street now. We have the
So now we
addresses.
get a street. What
Yeah.
what do we do? Map or flat map?
Flat map. Wait. Yeah, flat map. What? Addresses. You get addresses.
Flat map.
Flat map.
A to a dot street. What type is street? Street is a string. This was a list.
Yep.
This was a list. This was a list.
Company. Yep.
This isn't a list.
Yeah, it's not an array. It's going to be like a...
So if it's not a flat map, what should this be?
just a map, right?
Yep. In fact, what's funny is that if you do flat map, it treats this as list of char.
Whoa.
Oh.
But aren't we applying the map on the addresses?
We are.
Yeah. So like, would it actually matter if it were like, you know, flat map or map?
We're applying the map on addresses, but in here it's a single address.
Yeah. No, what I'm saying is, like, you know, the output would not be any different for either of those, right? Like map or flat map. Because I mean, anyway, we're applying the map or flat map on the list of address, and not on, you know, not on an address.
No, the last operation is fired on the A address object.
Yeah, it's not a list here anymore. It's an address. It's a single address.
Oh, I see what you mean. All right. Yeah. Okay. Fair enough.
A single
Yeah, the
address
string-
with a single
string
string.
is
Yep. I get it.
Yeah, string is actually an object, which is just an array of characters.
Yeah.
So if you do flat map, it'll compile, it'll check for it syntactically, it'll be right, but you'll get a wrong result.
Yes.
I follow it.
And then you have also the if statements, which would be filters.
Oh yeah. There should be.
Yes, correct. The if statements will show up as filters, and we'll introduce them in a minute. But anyhow, here's what it is fully typed, and here's what it is simplified. Here's what it is simplified. Right? Because in Scala you actually don't need to write out any of your types explicitly. It's all automatically inferred. Ah. Sure, Leia. Very soon, in just a minute. Leia, go back to bed, and I'll get you some more milk. Okay? Okay. So, now, yes, now we need to add our filters. Alright, so let's get this. Let's get that. How do we do that? Well, we just need some more filters there. So, let's add some filters. Companies.filter c2 c.name.starts with... Or wait, hold on. Was this companies? No, it's countries. We wanted to filter countries. Countries.filter c.name.starts with u. And then companies... Sorry, and then we wanted to filter people. .filter p.name.starts with j. So there it is. There's our pyramid of death. Now, you know, you could put the filters in line directly like that, if that's any simpler. But,
Pyramid anymore.
huh?
It's not a pyramid anymore.
It is not a pyramid anymore. It's a sequence. Now, here's the other thing. Let's go back to this form for a second. What about a situation where, and then let's take this. Let's take this form of it. What about a situation where, but we also want the country of the all the way out here. Let's say the name of the country, so US 123 Street, right? C.name plus that. But you can't do it here because you don't have this variable or this variable or this variable. Right? Can't do it. So, how can we fix this? Well, again, because the meaning of map and FlatMap, nested and flattened, is the same thing, let's just start flattening. Let's move this into here. And we can move that into there. And we can move that. And we can move all of this into there. And we can, and that's it. Let's see what this looks like flattened out. Da-da-da-da. 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 Da-da-da. And we're done. Voila. So again, because this form here and this form here is identical, the meaning is the same. So, oh, and by the way, if we need to add the filters back in, we can just add the filters back in. Countries.filter, people.filter. We just put the filters back in. So, all right, I'm back. So in Scala, this pattern is so frequent that there's a special construct for it. It is a for, but it's not a for loop. It's a for-comprehension, or a for-yield. And the way that it looks like is the following. C in countries. And then, sorry, dot companies. P in countries people. A in p dot addresses. Finally, yield a dot street. So this is actually the equivalent of this. In fact, this is syntactic sugar for this. And so, basically, everything inside here is a flat map, and this thing all the way inside the yield is going to be the final map. And that's the way all of these look. It's always going to be flat map, flat map, flat map, flat map, map.
And you can use the variables here as well, right? Like, you know, in the yield part, I could do c.name plus street.
Yes.
I mean, a.street, right?
Correct. Yes. Now, what about filter? What about filter? How do we use this construct with filter? Well, because...
You could add it inside.
Just put it inside.
Yep.
Voila. Voila. But in fact, there's even one more shorthand, and the shorthand for this is this. Like that. And like that. Right.
Oh, it looks like a switch statement.
Yes. Yes.
It does. But it's not really a switch statement.
No, it's not.
It's not even close, yeah.
Is this a pattern matcher? Or?
No, it's not a pattern matcher. It's
There is, Scala does have a pattern matcher. This isn't a pattern matcher. This will actually de-sugar to that.
Okay, interesting. I thought it might pick up the pattern match if starts with.
Yeah.
Okay.
Actually, no, starts with name is string, right? This is just going to be a string. Starts with is a method on a string, on a Java string.
Okay, right, yeah.
Now, this, again, desugars to this, including the filters. Actually, I'm lying, it's with filter. But with filter is lazy instead of eager, but the meaning is the same.
Yeah.
So, anyhow, so, huh? Okay.
So my roommates are talking.
Oh, all right, cool. So this is pretty simple. At least compare it to the death pyramid we had before. Let's compare this to this. All right, this is substantially nicer. So this is collections. This is collections. Now, everyone with me so far?
Yeah.
Yep.
Okay. Let's turn our attention to, or let's save this. The title of this, by the way, is The Monad Talk, and what that is will become apparent toward the end. But
You're
but
recording
anyway,
it, right?
huh?
You are recording it, right?
I am recording it. Yeah.
Cool beans.
So let's go on to something which is, let's go on to something that seems completely unrelated. Let's go on to asynchrony, processing things asynchronously. Let's talk about JavaScript. All right. Let's say we have some kind of API. Let's have we have some kind of person ID, which is some kind of integer 1, 2, 3, and we have an API, a HTTP API that allows us to look this thing up. So, what does a typical HTTP API look like? Well, something like this that allows you to do a wget. Something, something like people, some people API plus person ID. Or let's just do, let's do ID, whatever. Now, how do you process this asynchronously? Well, as all nice JavaScript APIs have, is they typically have some kind of way to intercept it with a nested block that has an on success, that has a function, right? This is JavaScript, and on failure, which is a function, and the success is going to have the response. That's going to be a string, but again, this is JavaScript, so it's not typed. And it's going to have a response code, which is an int, but again, JavaScript is not typed. And on failure is typically going to be a code. Now, let's say that we need to use this person, and we need to use the person to then look up the company, because only once we have person can we get the name of the company. Okay. Well, so the first thing we need to do is to get the actual person object out of here. The actual person JSON object, right? Because the response is going to be this big string, right, that's going to look like, blah, 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 name, Joe, and then a bunch of other stuff, and finally company, right? Let's say Microsoft, right? So we got to pull that out. Or let's say this is going to be, let's say this is going to be company, which is a string. Okay. Or company, let's do company name. Company name. Okay. So how do we actually pull this thing out, right? So let's say company name equals to, and then we have this wonderful JSON, or let's just do the whole person, right? Person equals to JSON dot of, or something like that, response, right? So then that's going to give us the actual JSON person object, from which we're going to be able to say person.company name, right? But here's the thing. We actually need that company name to call our next API in our sequence, which is to get the actual company object. What do we do? Another get. HTTP :// companies / plus company name. And like the previous API, we have this wonderful object that this returns. On success, a function that has a response and a code. On failure, function that has a code. All right, and then here, the response is going to be the actual company object. How do you pull that out? Same as we did before. Company equals to JSON dot of response. Okay. Now let's say we need both the company. Let's say we need the company ID and the person ID to get the person's tax information, like his effective tax rate, right? So, all right, so we need company.id and we need person.id. Great. Let's call our next level API. Get HTTP :/ tax info plus, let's say, person.id plus, and then another slash, company.id. And this is a good time to introduce the fact that Scala actually has nice string interpolation, where you could do that, and you could do that, and you could do that.
Oh, question, Alex.
Mm-hmm.
And in all the gets, it'll be like person, company name, and company dot whatever, right? Oh yeah, you already did that. I'm talking
Yeah.
I'm talking about the gets before that. That's all.
Huh? Company?
The get for company. Yeah.
Oh, you want to do that in the rest of them?
Oh no, not that. It would be like person dot company name, right? Because company
Oh yeah.
in that get.
Person dot. Yes, correct. Thank you for correcting me. In fact, let's do that. And then let's do that. I think that's a little more comprehensible.
Actually, JavaScript has templating too.
Yes, it does have it now. It does have it now.
Yeah, with the backtick.
Yep. So finally, our final sort of result here on success function blah blah blah, on failure function blah 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 blah, and then again this is going to be response and code, this is going to be code, and then finally we could do val tax info equals to JSON dot of response, and then we could, you know, who knows, update some DOM element or something, you know, something like document.get element by ID 123 or something like that, dot, you know, set value tax info or something like that. Right? So we're done. Now, what we did here, the funny part is that this isn't really anything complicated that we're doing. We're just doing a series of requests, right? Whoever thinks that this is a good API, right, is kind of crazy, right? Because the more that this pyramid grows, you move from left to right faster than you move down. And in the node world, this actually is called the pyramid of death. So, you know, and that's why they introduced something, you know, patterns like async await, in order to solve this specific problem. So Scala has a slightly different take on this, which is the following. But before we... Everyone good so far, by the way?
Well, yeah, but are you talking about chaining?
Well, yes, precisely.
Okay.
This is chaining in a nutshell, right?
Okay.
Huh?
I don't want to spoil it then, but I just make sure.
Yeah. So this is Scala's take on chaining. How do you chain, right? So before we do that, let's imagine that JavaScript was a slightly more, I don't know, I do not have a high opinion of JavaScript in general, if that hasn't come across yet, but, you know, I'm a little biased in that. But anyhow, let's make this slightly more normal, right? So let's call this API getPerson. And the response, let's actually make it person, right? So then we don't need to do that. And then let's call it getCompany. And then let's call the response a company. And then we don't need to do that. And then let's say getTaxInfo. And then let's call the response a taxinfo. And then we don't need to do that. So typing makes us a little bit more sane. But let's see if we can go one step further. So let's say getPerson. Well, let's say we just do that and we don't have a call with an object with a callback, but this is going to be async. What is this going to return? What's the type? So typically in JavaScript, what?
This would be a some kind of like request wrapper or something.
Correct. So either a promise, usually, right? So a promise, or a future person, right? And you can actually do something like future person.await, or you could do future person dot, let's say, on success, and that returns to you a lambda of person that actually lets you do something when that person is there, like, you know, who knows, update a DOM element or whatever, right? So this is a future. Now let's imagine that the future is actually a future object, and let's imagine that the future is typed. So it's actually typed on the thing that it's returning. So it's a typed future of person. Okay, well, that's a little nicer, I guess. Now, so let's say that we just want to pull out the person's name on success or something, and eventually do something with it, right? So p.name. Okay. So we just transformed it into a name. So now it's going to be a future name. This is a future of name, or of string, right? Does that make sense? So now we could do, again, we could do await on the future name, right? And that's going to actually, you know, in some languages at least, block the thread. Or something like that. But the point is that doing something like this, we are awaiting on a future that was originally person, but then once this future completes, then this lambda will be run on the output of that future, which is a person, and give us a new future of the person's name. Now, in Scala, there is another way to represent this, which is this. Right? This is a map. So, if this is a map, let's say that we want to make another call, another asynchronous call in the map, i.e., we want to start chaining. So, let's make our next call to get company. So, we get the person, say P in this case. We want to make the next call. Okay, what's going to be the return type of this? And again, hint, hint, the return type of this is future of company. The return type of this, right, the return type, yes, of this thing inside is future of company. The return type of this is future, the return type of this is just string, right?
Wait, so wouldn't the future name down there would also be string and not a...
It'd be a person.
Here?
No. I'm talking about, actually, I'm sorry, up there, in future name. Why is that still a feature of string if we're actually getting a string there?
Oh, no. Because remember, it's a map. P.name is a map.
Oh, right. Okay, it's a context, yep.
Right? Let's say if it's p.age. Age is an int. The output here is going to be an int. Right? Again, if the type is foo, say the type is foo, the output is going to be future of foo.
Oh yeah. Oh no. That's not what I was asking. Well, I was asking about like why is it even a feature there, since you were using a map on it. But then, never mind. I realized the error in that question.
So
The future of companies.
Huh?
The future of the last 300.
What?
Future, because you're getting a company per person.
You're not getting a company per person. What are you getting per person?
Oh, you're getting a future of a future, so it'll be a future
Yes.
of a future of company.
Okay.
Future of company.
Oh, but wait, hang on a second. I've got a question. Now here, does the map and FlatMap thing work here as well?
Yes, as a matter of fact, it does. That's what FlatMap is for. FlatMap is the composition for futures.
Yep.
Now, let's see if we can keep going here. Let's take this. Let's take this. And let's start this from scratch, right? Future person. That was future person was just that, right? Right, take note. We had this, right? And then that, because future person is just this, right? We just plug that into there. So we can just put that in there. Right now, let's flat map again. In this case, this is going to be C company. And again, we don't actually have to do this. This is going to be our company. Or let's call it, what are we calling it? CO? Let's call it CO. Now, let's do the next layer. Let's get the tax info. And then in this case, this is going to be P. This is going to be CO. And then finally, because we want, let's say, what did we want to get? We wanted to get the tax. We wanted, oh no, we wanted, what did we want to get? We wanted to get the, let's say we wanted to get the, what did we want to get for the tax info? Let's say the person's income, right? Income equals to tax info dot gross income, right? Let's say the income is double. Say we wanted income, right? So now, back here, we finally got the tax info. Flat map, what comes next? Map, right? The last one is always a map. Because this is future of person. This is future of company. This is future of tax info. But from tax info, we're not getting another future. From tax info, we're just getting the gross income. So again, same pattern. Flat map, map. So we're just...
Oh, I was going to say, that makes sense.
So, okay. But again, Scala has some syntactic sugar for flat maps and maps. So for yield. Why is this? Okay. For yield. P that happens from this. CO that happens from this. Tax info that happens from this. Yield tax info dot gross income. These are equivalent. Oh, and what do we get at the end? Output future of, let's say, double. That's the gross income. Same thing here. There's our output. Right, at which point we could do output.await, right? And then this is going to be value. Right, we could do that. Or we could do, again, output dot, because this is still a future, we could do dot map. We could do our whole DOM element thing that we wanted to update here. We could do that. But anyhow, so this is all things that we could do with it afterward. But these two forms here, these are functionally equivalent, or these actually are the same thing. This, in Scala, will desugar to this. So this is, basically, this is Scala's way of doing chaining of asynchronous calls.
Yeah, that's really neat. In Swift, we had something like a function would just and keep returning itself to was chaining.
Sorry, say that again?
Like a function would keep returning the type that it was, or to keep chaining it.
Yes.
So we had
Yes.
service that worked that way. So you can keep doing dot observable, dot as observable.
So, observable, it's actually funny because observable is just another name for future.
Right. Okay, that's what I was thinking.
So, in fact, the you can actually take a look at reactive what is it, RxJS observable. You actually look at RxJS observable, TDD, let's see, this is subscriber level stuff. Where's the RX?
I haven't actually used ArcsJS a lot, but I've used ArcSwift like extensively, and a little bit of ArcsJava.
So here we go, RxJS FlatMap. There we go. Concat map, exhaust map, merge map, flat map. There we go.
Yeah.
So there's flat map in RxJS. So basically, map and flat map, those are, you know, some of it's effectively the operating paradigm of the Rx series. All right. So again, because this for-comprehension is just syntactic sugar for flat maps and maps, or this most inner one is a map, because it's just syntactic sugar, basically this is the equivalent down here. Now, we have some fallbacks with the or else, so this is going to be, so this is actually, sorry, it's that, and it's that. So, because this is going to be the fallbacks, that's going to be that there, and at the end, that's going to be that there. Does that make sense? So,
Yeah.
okay. So, that's option. Let's go on to another thing that might seem completely unrelated, which is query. So, let's say we have something like this. Select name, age from people, or from person. Let's say person P. P.name, P.age. Now, if person was an actual collection, or something like that, what would be the equivalent of this? Or let's say people. If people was a list, what would be the equivalent? Right? Well, that would be people.map. P2, P.name, P.age. Right? That's got the same meaning there.
Yep.
But what's the type? What's the type of this?
Oh, it's a tuple, isn't it?
It's a tuple. Well, let's start simple. Let's say p.name. What's going to be the output? Let's say val people is list of person. Right? So this is going to be the output of this is going to be names, list of strings.
Strings. Yep.
The output of this is going to be val names and ages. The output of this is going to be a list, and that's going to be a tuple string int. So that's if it's a list. Here's an interesting question. What if this is a table of person, right? Like, what if this is an actual table, like a database table of person? Well, let's start with this one because it's easier. Let's say people is a database table of person. If you actually want to find the meaning of what this is, and sorry, it's that, right? So that when I say it's a database table of person, I mean an actual, proper table, right? That's got, ta-da, right, right, name, right, da-da-da, space, right, next, age, da-da-da-da.
Multi-line cursor is the goat, isn't it?
Yes, multi-line cursors are very nice. Da-da-da, right, and then this is going to be Joe. This is going to be 123 Street. Right, this is going to be Jack.
Hey, age can't be string.
Oh, we're up. Whoops, sorry. I was thinking address. 456. Whatever. Right? These are our people.
Yep.
Jack has lived for a while. Isn't necessarily human. But anyhow, so that's table of person, right? Now, what about names? Val names. What's a table of string? Well, a table of string is going to be some column header, and that's it. There's your table of string. So this, if people is table of person, this is table of string. And this is table of string int. Now what's interesting, by the way, is this, right? People is also a class that has a string and an int. So this, person, right? Case class, person, name, string, age, int. This structurally is equivalent to this. A person is a string int that just happens to be called person. So structurally, they mean the same thing. Of course, the notion of object-oriented programming allows us to take a list of fields. It allows us to take a string int and call it a person. That's what object-oriented programming is. We have a list of strings and ints and other stuff, and we call it by a certain class name. Hence, we can actually have something like this that means the same thing as this. So, let's get to where we're going with this. So this is how we can do select stuff from a single table. The other name for this is a projection. Now, what about a join? Right? Well, remember that, let's say we want to join people and addresses. Right? So, before we had case class person name string age int, and then we had addresses, and that was list of address, right? Now, what we did before when we wanted to, get people and the addresses that they had is we had our for-comprehension. Why is this? We had our for-comprehension, and we had p in people, right? And then we had a in p.addresses, right? And then we could yield a or p and a, something like that, right? Well, now, because we're in database land, we don't have this, right? In most databases, you don't have records with embedded arrays. Instead, what you have is this. Address, right? And this is going to be that, and then this is going to be ID, or let's just have owner ID, right? And this is the foreign key. And inside, this is going to be ID. That's what we're going to have. And then we're going to have a table. Let's say we're going to have a table, or val people, which is going to be just table of person, or val addresses, which is going to be table of address, right? And that's what we're going to have. We're not going to have these nested structures. So we can't do p.addresses. We can only do addresses. Well, that's a problem, right? Because this is all the people and all the addresses. What is this gonna yield?
Oh, is this like a... What is that join called? Is this the full join? No.
Yes.
Oh, it is a full join.
In other words, my favorite term, Cartesian product. Right? This is going to be a table of a tuple person address. Whoops! So, but, right, we don't want that, right? The equivalent of this is select p dot star a dot star from person p address a where a dot, let's say where, or nowhere, excuse me.
There's nowhere.
Nowhere, right?
Yep.
But how do we get only the addresses for the particular people who they belong to? Well, add a where clause. How do we add a where clause here? Filter! Filter! Right? A2, because we're filtering addresses.
A dot something.
A dot owner ID equal to P dot ID.
Yep.
Right? There's our where clause. Where A dot owner ID equal to P dot ID. Right? Ah! There is another term for this. Right?
Yeah.
Well, okay. This is, to be fair, this is a implicit join. An explicit join is this. That.
Yep.
And then instead of the where, it's an on. But does it really have to be an on? Right? This can also be a where, right? If you take it out, it's a full join, i.e. Cartesian product, i.e. what we were talking about before. And as opposed to that, right? So it's the same darn thing. So this is a regular join. Ah ha 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 ha. But oh, first of all, this is interesting, right? So this all the way before we introduced any of this, this was a Cartesian product. Right? This was a Cartesian product before the filters, right? This is going to be Cartesian product. Cartesian product is actually a very specific type of product. It's a categorical product. See, in category theory, the product of person, address, is the set of all people and the set of all addresses. It's a categorical product. When dealing with Cartesian systems like tables, we call it the Cartesian product. Every single join in all of the universe is just a frickin' subset of the Cartesian product. Now, what about left joins, right? So left joins, right? If you remember that whole Venn diagram that they do about left joins, I think I've mentioned this before. I can mention this again. The Venn diagram is a lie, actually. The only way to properly describe a database join is by using this product, right? Or there's another way that we could write it, which is going to be and. Let's call it a V, right? That's a product. Or is that, no, sorry, caret.
Oh yeah, that's
right. Now, there's the definition of an actual join, or a product. Now, what about a left join? A left join, one hand side could be null. Well, here's what a left join is. Say we're left joining address. Address or null.
An option of that.
Huh?
You mean an option of that?
What is the definition of null? Or what is the definition of empty? What is the definition of address or empty? Let's say that we actually have a type system that has an operator. Again, this is on the level of types. This isn't on the level of values. Right? Or null. Let's say that we have address or null. What is the type of address or null? Type option T equals to T or null. There's your definition of what option is. This is not the case in Scala. This actually will be the case in Dotty, or at least conceptually, because in Dotty there will be such thing as an OR type, right? Like you will be able to do string or int. Type, let's say type foo, is a string or int. So a address or null is actually an option of T. In other words, this whole thing is person or option of address, or person, and option of address. So it is the categorical product or Cartesian product of person and an address or null. This is called a Cartesian sum. So it's the product of the sum of address or null. There.
Did you say Dotty?
Dotty is Scala 3.
Oh, okay.
Yeah. But anyhow, more on that later. Really, almost every single thing in programming we do at all ever is just a categorical product or a categorical sum. An enum is a categorical sum. It's a list of possible things. A class is a categorical product because it's a bunch of things. It's a bunch of strings and ints, right? This is, or sorry, not this, blah, 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 what were we saying? String int, right? This is the same as person, right? Because person is a string int. Person is nothing more than the categorical product of string int. Tuple is nothing more than the categorical product of string int. Hence, person and tuple string int are the same, i.e. isomorphic. Anyhow, all that later. So here's our join. Right, here's our join. Oh, and by the way, if it's a left join, as I've said before, it's an option. Right? This is actually not going to be address, right? It's going to be option of address. So there's our left join. So, but again, keep in mind, let's go with this construct here. All of this is just syntactic sugar for Map and FlatMap. Right? Let's desugar this. What is this actually? It's people dot FlatMap p2 p dot addresses, or sorry, no, not, right? There is no p dot addresses. Yes. So it's addresses. Yep. Dot, and then there's our filter in here. Right, but let's ignore it for now. Let's say there's no filter. Let's just deal with this generic case. Right, dot map a, and then finally we're yielding a tuple, p and a. Oh, and by the way, if we have our filter, where did we have it?
Oh, down there.
There we go. If we have our filter, which is our filter here. Oh, by the way, just add it here. And that's the same thing.
Wait, before the map, yep.
Yeah. So we can have variation with the filter, we can have variation without the filter. Again, it's the same darn types with and without the filter. So, all right. We've done a bunch of things. We've done collections, we've done asynchrony, we've done options, we've done queries. Let's finally bring it all together and call it a night. Let's start from the beginning. What did we have in the very beginning? We had people and addresses dot flatmap. Where did we have? People and addresses dot flatmap. Here's what we had. List of string, people.flatmap, addresses.flatmap, where people had a list of addresses inside of it. Okay, let's just do a.street to be simple. So there we had lists. Now, let's go on to future. Where did we have future? Blah, blah, blah. Here we go. FlatMap get company. That gave us future of company. Okay. Oh, and let's actually do a final map. Let's just get the company name. Okay. So there's futures. Then we had optionals. We had this. And this was, let's take away our fallbacks, make it a little simpler. And then let's just skip bar. Or let's just do bar.map, foo_val plus bar_val. Make it a little simpler. Val output, that's going to be option of string, right? Okay. Now, let's go, or let's move this here. Finally, what we just had a second ago, our query map this, which yielded table of person, address. But again, let's just simplify. Let's remove the filter, and let's just return an address from all of this, and ignore person. Doesn't make much sense, but whatever. Okay. Now, let's zoom out a little bit. Okay. We have lists. We have futures. We have option. We have table. Can anybody see a pattern?
Yay, yes.
Anybody see a pattern here?
I mean, I'm still following. They all map things.
Flat map, flat map, map. Flat map, map. Flat map, map. Flat map, map. They're the same frickin' thing.
Yeah.
They're all the same frickin' thing.
It's as if they have their own, somewhat implementations of
Yes.
FlatMap.
And by the way, when I say table, this is actually query.
Query. I was gonna say that. Hey.
And that's quill.
Don't you?
Oh, by the way, all of this is not table, it's query. This is quill. Quill is the implementation of query. And by the way, one other dirty detail is that has to be quote, like that, like that. Why that is the case, long story. But it's not table, it's query. Okay. Just a small detail. Anyhow, so they're all the same frickin' thing. Now, we actually had an implementation of Map and FlatMap. Right? We went through this. So, class list def map. Let's say list is list of person, right? And then let's say we had a map. A map was, what did map give us? Map was a lambda of person to, what was it here? Or let's say it was address. Right? Map here was address mapped to what? What was this lambda? What was the return type of this lambda?
Oh, it was a string.
So it was a string. What was the return type of this whole thing?
List of string.
List of string. Okay. Now, what about, right, but again, let's call it T, which is the input type. Let's call it R, which is the return type. Now,
There we have it.
def flat map. What is it? T2.
Same thing.
Close, not quite.
Oh no, not really, but almost. Oh.
Array of R.
Yeah,
Huh?
It's gonna be R.
List R.
Yep.
Then you get
List of R.
right.
Let's try future. Future of T. Map F2. Type R. Right, in the beginning we had person, and then we went to string because we wanted the company name. So person to string. What did this give us back?
Future of string.
Future of string. And again, let's call the record type T. Let's call it R. T went to R, and this was R. What about flat map?
Yep, same thing as before, except with future, as in future of R. I mean T2. It returns a future of R.
T to what?
Future of R.
Future of R returns future of R. Right? Because we started with company, we started with person, right? And then we went to company, right? And then we added person to future of company, which is that, right? That's returns future of company, right? That's what that whole thing returned to us, right? So we had that. And then what was the result of the whole thing? If you take this out, the result of the whole thing is also future of company. This whole thing returns future of company. So it really is R, person is T in this case, future of R. Right? Okay. Okay. Now, next, option. Option of T. Map. R. F2, what's it going to be?
T to R.
T to R. I'm sounding like a broken record here. T to R. Def flat map. R, what are we going to be?
F T2 option of R.
T2 option of R goes to
Option of R.
option of R. Next, finally, query. T.
Yep, same thing.
Same thing.
Except
Def map R. F of T2. What are we going to be?
R.
R. What's that going to give us?
Query of R.
Query of R. What about flat map? R. What are we going to be?
T2 query of R.
Right? Query, right? We map, this is this thing. Let's take this out, right? This, whoops. This is query of address, right? This was query of person, right? We went from query of person. This was person. We went query of person to query of address. Right? Person 2, each one gives you a query of address. Addresses is query of address. That's each one. So person to query address. This gives you query of address. So this whole thing gives you query of address. And again, person is T. So this is going to be T. Address is the return type, R, R, R. Now, let's just take all these things we wrote down and compare them. List. List. Future. Future. Option. Option. Query. Query. Now, let's see if we can find a pattern here. Let's make a class called Flappa Mappa of T. What is map going to be?
T2R.
F, T to R, our return type. What's going to be the output?
Flapper mapper of R.
Flappa Mappa of R. Def flat map R.
It'll be R. You put a T there.
Oh, whoops. Thank you. Thank you. What's flat map going to be?
T2 flapper mapper of R.
Flappa Mappa of R. What's the output going to be?
Flapper mapper of R.
Flappa Mappa of R. Right? They're all the same freaking thing. They're all the Flappa Mappas.
Yeah, they're all
And the name, the official name from math of Flappa Mappa is called Monad. Monad, monad, monad.
Oh, that's what a monad is?
That's what a monad is.
Oh. Oh.
It all makes sense.
It's basically the only thing that a monad actually does is it flattens pyramids of stuff. That's what it does. whether it be a pyramid of for loops, or a pyramid of asynchronous calls, or a pyramid of if statements that do null checks, or a pyramid of nested query thingies. It just flattens pyramids.
Alex, question. So in actually the compiler level, do all these lists, features, option queries, they actually just, I don't know, inherit monad?
So they don't.
Oh.
They're
So they have their own implementation of maps every
correct.
downtime.
Correct. The reason why they do not inherit monad is because monad is such a ridiculously high-level concept that in any kind of polymorphic system, it just doesn't really make any sense. Because these things, it's kind of like a super pattern. It's just there's no value in a polymorphic way of representing it, because the thing about it is that these kinds of the kinds of different things in which it's going to be inside of are just like way too vast. That said, in Haskell, as well as in Scala, in very very functional programming libraries like Scala Z or Cats, in those ecosystems you will actually see monad, but monad will not be represented as a class. It will be represented as a type class. And what type classes are is that's another lesson. But the idea of type classes is that type classes are a different way of doing polymorphism. Object polymorphism, or as we call it, parametric polymorphism, is a tree, right? Objects, your inheritance hierarchy forms a tree. And at the top of the tree is going to be object. Maybe there's also going to be something at the bottom of the tree. There isn't such a thing in Java. There is such a thing in Scala. But monad would be near the top of the tree, and it really doesn't make sense to put it there. However, if your system of polymorphism is not a tree, if it's a graph, and that's what type classes are, it's a system of polymorphism which is a graph, then it starts to make sense to put something like monad in there.